equations to represent the motion of an object. So we're going to go through the different expressions, and in this unit we're going to have a handful of equations that we're going to be able to manipulate to find any unknown. So your job is not to memorize equations, because the equations are all given on your equation sheet. The key for you is to know when is appropriate to use each one. Here are all the equations for motion, and actually it looks like there's a lot, right? There's like 7 here, but there's actually a lot of repetition within these equations. So I want to show you why I'm saying that. If we go through these, we can check off which things are present in each column. So for this first equation, this is actually the definition of average velocity. It's the change in position over the change in time. And you can see you've got displacement, you've got time. Let's make a column for V average here. So we've got change in position or displacement, time, and average velocity. We've got in this equation, this says V average again, but now it says 1/2 of V initial plus V final. So this means that I can find V average in 2 different ways. I can find it if I know displacement and time, or if I know the initial and the final velocity. Both of these are definitions, right? Because an average is you add 2 things, divide by 2. So this is actually the definition of average. This is what average means. And this one up here is the definition of average velocity. This equation is the same as this one, it's just rearranged. You see how this part of the equation here is average velocity? And if I rearrange this and I do multiply V average times time, that equals displacement, that's what this is. So now I've got an expression that has all of these parts, and it eliminates the need for the intervening step of finding average velocity if you're not asked for it. So this is a combination of the first 2. This is the definition of average acceleration. So acceleration is the change in velocity, not just velocity, it's the change in velocity over the change in time. To find delta V, the change in anything is the final minus the initial. So if I want change in velocity, I need V final minus V initial. If I wanted to know change in position, it's X final minus X initial. So I need both of these and time. This expression is exactly the same as this one. These are the same. They have the same exact variables. So look, initial velocity is here, final velocity is here, acceleration and time. So I've just rearranged the previous equation. So notice I have delta D, I have the initial, time, and acceleration. So this is a combination. And I'm not really interested that you know how to combine them, but what I'm interested in you knowing is that this is not, you could use the 2 intervening expressions or just use this one. So this equation is a combination of 2 other equations. This one we have V final and V initial and acceleration and delta D. So this is the same thing. It's a combination of 3 and 5, but it gets rid of time. Now I want you to notice in these expressions, the main ones that we will make use of are these last 3. This one, and this one. And this one, not as much, but it will come up sometimes. But these are the most common. And why is that? Because look what we don't have. Each one of these, if we just use these 4, we have one equation that has 4 out of the 5 and not acceleration. This one has 4 out of the 5 and not displacement. This one has 4 out of the 5 and not final velocity. And this one has 4 out of the 5 and not time. This means that these 4 equations are a really great bank of equations to use for any possible kinematics problem, with the exception of average velocity. To find average velocity, you're going to need to probably use this first one more than any of them. And that's the one that you will find yourself often defaulting to. Be careful. On that note, let's discuss how you can tell whether or not you should use that average speed equation. You should only use the average speed equation in two situations. You are expressly told that there's average speed or average velocity requested. Either you're trying to find it or you are provided with the average speed. Or you know that it's constant speed. Those are the only two times you should ever use the V equals delta D over delta T. I'm emphasizing that because most people, you try to use that equation all the time, and that is not going to work. You need to make a sketch, list or label givens, list or label unknowns, draw a motion diagram. That's a new piece. Check the signs once you've made a motion diagram. You're then going to choose the equation, plug in numbers, you do your algebra, then you write your answer with units. So the new portion of this is going to be drawing the motion diagram and checking your signs. And what information you label, of course, will be different, and what equations you use will be different, but the setup of the problem is no different than in previous units that we've done. So let's go through the problem-solving process. First thing you have to do is you have to draw a picture. So we're going to do that, and we always label velocity, position, and time, and acceleration. So I would call this V1, V2, and now I'm going to label everything. If it takes 8 seconds, so 0 to 8 seconds, it's going 18 meters per second here to 30 meters per second. This is 0, we don't know that, we don't know acceleration, and we're asked to find average velocity. You want to show which way is the positive direction, and we know we're increasing speed, so you can show a motion diagram in the direction that it's moving, and you want to associate these arrows with signs. This is your axis in the positive direction. That means that velocity is positive and acceleration is positive. So this is positive, this is positive. So we don't know acceleration, but if we were looking for it, we would want that to be positive also. These are important things to note. Now we could pick an equation. If you look at your equation sheet, you'll see that there's two equations that you could use to find average velocity. It's this one or this one. So how do you choose which to use? Well, do I know the change in position? I would have to know x1 and x2. I do not know x1 and x2. Therefore, I cannot use this to find average velocity. Instead, I'm going to do 18 plus 30 and divide that by 2. So that's 48 divided by 2 is 24 meters per second. You throw a 1 kilogram ball into the air with an initial speed of 12 meters per second. How high does it go? We have a ball here and it moves up. So we're going to label again VYT and VYT. Now why am I using a Y? Because now I'm moving along this Y axis. So I don't want to use X because X is implied horizontal. I start here, so I'll call this 1. I end here, I'll call that 2, or you can use initial final. And acceleration is in between the two velocities. So what do I know? Well, it tells me a 1 kilogram ball. That means the mass is 1 kilogram. So I'm just going to note that down. It has an initial speed of 12. So that goes here. We start at time 0. I'm going to call this 0 on my y-axis. We're looking for how high does it go. So that's this. And what's implied in here is what's its maximum height. And at maximum height, for an object in free fall, the velocity is 0. So even though it's not overtly stated, we know that this is true. Acceleration of an object in free fall is always 9.8 meters per second squared. And we always decrease speed, right? We're going to start at 12 and end at 0. So we're decreasing speed on the way up. Therefore, acceleration must point down. Now, if we assign the signs, this is positive is up, so the velocity is positive, but acceleration is negative. So we want to check that, make sure we put this is positive and acceleration is negative, which should make some sense. Now, how do we pick an equation? Well, I make my list. And I go, yes, I have this. Yes, I have this. Yes, I have this. This is what I'm looking for. So I need an equation that has these four things and not time. So that, if you look at your equation sheet, is this equation is the only one that does not have time in it. Then we can plug in the givens. This is 0. This is 12 squared. Acceleration is negative 9.8. So this is 0 equals 144 plus negative 19.6. I just did 2 times negative 9.8. I'm going to subtract 144 to the other side. Subtract 144. And what's left to get delta D by itself is to divide by negative 19.6. So let's do it. Now you might be wondering why I left off the negatives when I put in my calculator, because in my head I already did it. I know that a negative and a negative make a positive, so I didn't type that in, but you can. Make sure you put units on your answer, and then you're done. The water balloon is dropped from a 10-meter high window. How fast is it moving when it hits the pavement? So here's the balloon, here's the balloon, V, Y, T, V, Y, and T. I'm going to call this 1 because it's dropped from the window, and this is 2. So this is my setup, and you'll get used to it. Doing it this way means that you'll do it the same way every time. I'm going to make positive y-axis point up, and it's dropped, therefore it starts at rest. This implies V initial 0. We're starting at 10 meters high and ending at 0, or ending at the ground. And we don't know how fast it's going because that's what they're asking for. You might think, oh, it must be 0 when it hits the pavement. But as we discussed, we're talking about a split second before it hits the ground. And we know it starts at time 0, but we don't know how long it takes. And all objects in free fall have an acceleration of 9.8 meters per second squared. We are increasing speed on the way down, so acceleration must point down. Since positive is up, my velocity has to be negative and my acceleration is going to be negative. So I'm going to put my negative sign on my acceleration, and if my velocity doesn't come out negative, I have to see what mistake I made. So I'm going to make my list again so that I can pick the right equation. You take out your equation sheet and see we have this, we want that, we know this, and we know that. So once again, we have everything except for time. So the equation we have to use is this one. So this is what we're solving for. This is 0. And delta D is 0 minus 10. So be careful because delta D, remember, is y final minus y initial. So it's 0 minus 10, which is negative 10. So just be aware. Okay, so V final equals, so this is 2 times 9.8 times 10, which comes out to be 196. And if you take the square root of 196, you get 14. Now your instinct is just going to be to write 14 and be done with it. But what did we just say about the sign of velocity? Velocity has to be negative. It didn't come out negative. Why not? Well, the square root of any number, you can get either a positive or a negative root. It is your job to make sure you assign the correct sign to the value. That's why we do motion diagrams. This problem has a car traveling at 23 meters per second. So, and then it comes to a sudden stop. So V, X, T, V, X, T. In between is acceleration. We know this is 6.25 meters per second squared, right? We come to a sudden stop. We start at 23 meters per second. The beginning position and time are 0. We're trying to find the maximum braking distance. That's this. We are not interested in the time. If this is our positive direction and we are slowing down, That means that if this is positive, then velocity is positive, acceleration is negative. So let's make sure we label the signs. I make such a big deal about this because I can't even express to you how many people do such a great job and then they make a silly mistake by forgetting that. And then it just will limit you to getting proficient, which isn't bad. It's just like for something so simple, you really could do one small adjustment and you'll be able to get it right. So this problem calls for this equation. How do I know? Well, I have everything except for time. This is the equation. If you go back to the chart, the only one of the four that doesn't have time. So this is 0, this is 23, this is negative 6.25, and I can solve for distance. So 23 squared is 529. 6.25 times 2 is negative 12.5. So I have to subtract this to the other side. And divide both sides by negative 12.5. So negative 529 divided by negative 12.5 is 42.3 meters. And that's how you solve these problems.